Alright, the experiment we're going to do today is extractions with solvents. Alright, so what we're going to have is we're going to have a propanoic acid solution. So we're going to put propanoic acid in water. Then we're going to use diethyl ether or ethyl ether or simply ether. If somebody wants a bottle of ether, they want diethyl ether. Alright. The UPAC name is ethyl ethanoate. I've called it all the three things above: diethyl ether, ethyl ether, and just ether. And everyone knows that that is diethyl ether. I'm not sure if I have ever called it ethyl ethanoate. So that is the UPAC name. That's not used hardly at all. Alright, so what we're going to do is we're going to then add our diethyl ether. And since you have your diethyl ether has an oxygen, it is bent, the shape is bent, so it is polar, and so there's going to be solubility with our diethyl ether and our propanoic acid. And so we're going to extract or remove the propanoic acid from the water using the diethyl ether. And to determine how well we did our extraction, taking the propanoic acid out of the water, we're going to do a titration. Alright, and so the titration that we're going to do is it's going to be using 0.083 molar NaOH. So that is the concentration of the base that we're going to use today for our titration. And we're only going to give two significant figures for this experiment. Alright, so we have our propanoic acid, 3 carbons, propane, carboxylic acid, so it is propanoic acid. And we're going to react that with our base NaOH. And so the mechanism for organic chemistry, we will write a arrow pushing mechanism. The electrons from the negative oxygen will attack the acidic hydrogen on our propanoic acid, and the electrons from that carboxylic acid OH bond are going to go to that oxygen. And so the product is going to be the deprotonated carboxylic acid. So that is propanoate, right? And so this is sodium propanoate. So it's the same nomenclature as we did in Gen Chem. The ic acid in the propanoic acid goes to 8. So we know sulfuric acid is H2SO4. We know sulfate is SO4 minus 2. So the ic becomes an 8. So that is sodium propanoate. And then, of course, water. And so it is a balanced chemical reaction where our coefficients are both 1. And so our titration equation is molarity times volume over the coefficient of the acid is equal to the molarity times the volume over the coefficient for the base. Both coefficients are 1. It is a 1-to-1 balanced reaction. Alright, so if we then calculate this, we will have our volume of acid. We're going to use 10 mils of this acid. And we know the molarity of the base. I gave that as 0.083 molar. And then we will get the volume of the base by our titration. And again, both coefficients are 1. And so we will calculate the molarity of our acid, so the propanoic acid. And now to convert the molarity into the mass, you then will multiply it by the molar mass, which you get from the periodic table of your propanoic acid, and that will give you grams per liter. And we're going to use 10 mils, and so to convert the 10 mils into liters, it is 0.01 liters, and that will give us the mass in grams of our propanoic acid that is in the 10 mil sample. Alright, so we're going to know exactly how many grams of our propanoic acid are in a 10 mil sample of our propanoic acid solution. So then we're going to do the extraction with the diethyl ether, and we're going to do it 2 ways. We will do it the simple method, which we're going to take 15 mils of diethyl ether one time, and we will then separate it in our separatory funnel, which I will show you a proper way to use the separatory funnel. and then we'll see how much of the propanoic acid was removed by using a 15 ml sample. Then in the multiple extraction, we're going to still take 15 mils of our diethyl ether, but we're going to do it 5 mils and extract, and then we're going to extract with another 5 mils, separate it, and then another 5 mils and separate it. So we're going to separate it 3 different times and see if that takes out more of our propanoic acid, which it should. All right, and so we are going to show that a multiple extraction will remove more of the acid than a simple extraction using the same amount of the solvent. All right, so here is our setup. We have our diethyl ether ready here in this bottle. In our burettes, we have on the left, we have our propanoic acid solution. On the right, we have our 0.083 molar NaOH. We've got our phenolphthalein for the endpoint. We've got our Erlenmeyer flask to do our titrations that everyone is familiar with. And then our new piece of equipment that we haven't used yet, and that is a separatory funnel. So it is a pear-shaped funnel. And I will, when we do our extractions, I will give you the rules for using our separatory funnel. All right, so let's begin the experiment. All right. So first, I'm going to take 10 mils of the propanoic acid. This is just deionized water wet. All right, and so I'm going to use my burette, and so this is at 2.20 milliliters, 2.20. So that is the starting volume. And so I want to add 10, so I'm just going to go down to 12.2. All right, so I'm just going to add this until it is at 12.2. All right, so now we have exactly 10 mils of our acid in here. So exactly 10 milliliters. So 10 milliliters, we're at 12.20 mils. So 10.00. So now we're going to do the titration. First, I will fill this with our NaOH solution. Make sure we have plenty. All right, so this one we're going to need both the initial and the final. We were putting in exactly 10 over there. We didn't need our initial and final. We just need to know how much we put in. All right, so here we have 0.62 milliliters. 0.62, all right? Now we're not going to get a color change if we don't add phenolphthalein. So we will add 4 or 5 drops of phenolphthalein. All right, and then we are going to add our NaOH until we get, and we know the phenolphthalein is working, when it hits, you get a little hint of pink and then it quickly disappears. All right, and so we were going to keep adding our NaOH until our solution stays pink for 30 seconds. At least 30 seconds while swirling. All right, I keep saying that I'm going to get my magnetic stirrer out, but I keep not getting my magnetic stirrer out. So I will swirl this. So it hits, it's got the pink color, quickly disappears. When that pink color starts lingering longer and longer, I will slow down the drip rate. All right, Alright, so now it's lingering quite a bit, so I'm going to slow it down. Very close. I can add it a drop at a time, but again, it's got to stay for 30 seconds while swirling. Add another drop. Alright, let's see. That's not going to stay. That's not going to stay. Very close to the end point. That, very close. All right, that should do it. All right, let's see if this stays. All right. So it's still a light pink, and so that is our endpoint. So our final reading is 12.88. So 12.88 milliliters is our final reading. All right, so that is the first titration. All right, so now we need 10 mils that I'm going to put in this beaker, and then I'm going to transfer it to our separatory funnel. All right, so we are at 12.2, so now I'm going to go down to 22.2. So 22.2 right there. And then we're going to put that into our separatory funnel. All right, and also in our separatory funnel, we're going to put 15 mils of the diethyl ether. And it says no flames because diethyl ether is very flammable. The vapors of the diethyl ether are heavier than air, so they stay low. So as we are pouring some ether out onto the bench top here, you can see why we would not want any flame. So it quickly evaporates, but the vapors are staying lower than air. It doesn't go up like the normal evaporation would occur. And so you have a buildup of vapors right here. If you would light a match, you would get a flash fire on the surface of this table. All right, and so we have 15 mils that we will, to make sure all of our 10 mils comes out of here, we will put in the 15 mils by adding it to this beaker and then pouring it in. All right, so now we have our two layers. Let's see if I can get that closer to the video. All right, so there's two layers. Right there, there is your layer. So on top, you're going to have your ether. It is less dense than the water. So your aqueous phase, the water level, is at the bottom. It has a higher density. All right, so your higher density is always at the bottom. All right, but we need to make sure that this mixes up. We want to have the ether extract, remove the propanoic acid from the water. And so your ether is very volatile. It evaporates quickly. I spilled some on the desk. It was gone a long time ago. It immediately evaporates. All right, so when I seal this, it's going to build up pressure because of the evaporation. This is where it gets a little tricky. All right, and so I'm going to seal this. All right, now it's in a sealed container. Then I'm going to put my 2 fingers on the top, and then I'm going to slowly turn it upside down. And then I'm going to vent. So listen. All right, so you hear the vapors escape. You hear a whoosh. All right, and that was just going very slowly. So I will do it again. And you could still hear it, but it was not near as loud. And then you could hear it again. Again, it's not as loud as the first one or the second one. And now I'm going faster, and you can barely hear it. All right, and so when you can't hear it at all, when you are venting, now you can mix it up, and then when you turn it up, you have 0 vapors coming out. It has reached its equilibrium. Now, if you would do this to start with, the pressure would build up so much it would pop, the top would be popped right off. All right, so we have thoroughly mixed our ether in with our acid solution. I don't hear anything. All right, so we put it back up here, and we're going to stick it in this iron ring. All right, and we're going to let it separate. Now, another key is if I try to get the water level layer out, you have to remove the top. So this is like a straw with your finger on it. I open this up, it's not going to come out. So if you are wondering why your solution is not coming out, it's because the top is still on your separatory funnel. All right, so we are going to collect our aqueous. All right, so again, the bottom layer is the aqueous layer. And so we're going to collect our aqueous layer with the acid in it, and then we're going to titrate it, and then we will see how much acid we have left in the water layer, and the remaining acid is in the your organic layer, the ether layer. All right, so now you have to remove until the line of your water. So this is immiscible liquid. You have your polar hydrogen bonded water, and you have your slightly polar ether, but they are not miscible. They do not mix. All right, and so we're going to then take off the bottom layer. So when all of the aqueous layer is then in your Erlenmeyer flask. So now you're ready to do another titration. All right, so we want to fill up our base. All right, so this time our initial volume is 2.70 milliliters. 2.70 milliliters. Again, we're not going to get a color change unless we add our phenolphthalein. So let's add 4 or 5 drops of phenolphthalein. All right, and now we're ready to do our titration. So again, we're going to titrate it until it stays pink for at least 30 seconds. So it can go in pretty quickly. When the pink lingers, we will slow it down. Right now, as soon as it hits, it turns pink and disappears. Now we're getting to where is it going to stay pink here? Alright, well, I took out a lot more of the acid than I thought it would. Just to make sure it's going to stay pink. Alright, looks like it's going to stay pink. And so the final volume of our NaOH is 6.10. 6.10. Alright, so that took out quite a bit of our acid. Alright, so this time we're going to take put our acid, and I guess we don't need to go too much. All right, so this time, well, let's figure out our ether. So ether's going in there. Okay. All right, so we're getting our 10 mils. So it's starting at 1.0. We need to go down to 11.0. Okay, there's our 10 mils of acid that we will put into our separatory funnel. All right, now this time with the ether, we're going to use 15 mils of ether, but we're going to use it 5 mils at a time. All right, so we're going to add 5 mils. All right, so I'll put it in here, make sure we get all that acid out and into here. There. All right, so this is our first extraction. And so the same rules that we had last time. All right, so we have our 2 layers. Now this time the 2 layers, it's up higher because we only have 5 mils of ether, so there's only 5 mils on top instead of 15 last time. But you have your same 2 layers. All right, again, the first time you have to be very careful. So you don't point this at anybody, you point it away from people. You don't want to shoot ether at them or the propanoic acid with the ether at them. All right, so now it's not making any more sounds. So you can get a little more violent with the mixing. Still a little bit, but still a little bit. All right, so now I didn't hear anything that time. All right, so we have thoroughly mixed this. So we put it back up here. Again, remove the top or the water layer will not come out. All right. I will get another beaker. All right, so now I'm going to put it in a beaker and not a Erlenmeyer flask because I'm going to pour it back in here. So that was just the first of 3 extractions. And so I'm going to take this out. And as soon as my layer is down in this stopcock, alright, so then I close it. So all of the aqueous acid and all the acid that's in the ether here, the ether layer. So I'm dumping out the ether layer into my ether container, my used ether container. Alright. Alright, now I'm going to do it again. So I have my extracted acid that I'm pouring back into it. All right, and then I got to get 5 mils of ether. Okay, 5 mils of ether, and I do it again. So again, I want to make sure that all of it came out. Pour that in here. All right, so it's all back in. Again, I'm putting the lid on, tilting it up, releasing the vapors, release the vapors. All right, so it is thoroughly mixed up. All of the ether is interacting with the aqueous layer, taking out the propanoic acid. Okay, put it back into our beaker again. Again, I should have left that on there to show you what it does if you don't remove it. But anyway, the water layer will stop coming out once the pressure gets too much from leaving the lid on. All right, so I'm going to take out the water. I put the ether into the ether waste. All right. There, no, okay. All right, so I put the water back in, and then my third 5 ml sample. For third 5 ml ether, and so I'm going to use the same amount as I did with the simple one. I used 15. This time I'm using 5 3 times. So the amount of ether used is the same. sure all of the aqueous acid goes back in. All right, so now we have our 5 mils of ether again. Put the lid on, vent, vent. So the less noise, it's reaching its equilibrium, and then you're able to mix it so that the ether is interacting with the aqueous layer, extracting the propanoic acid. All right, so we are ready to remove. This time we're going to put it in our volumetric flat or Erlenmeyer flask because we're going to do our titration. This was the third and final extraction. All right. So now we're ready to do our titration. We'll add our 4 or 5 drops of phenolphthalein. We are at 6.10, yes, 6.10, so that's where we're going to stay, 6.10. All right, so then we're going to add NaOH until we get this should be relatively quick because we should have extracted most of our acid. lingering. It's getting close. All right, it is still pink, and that is our endpoint. And we are at .50 milliliters. All right, so those are the data points that you need to calculate how much was extracted by using it 15 mils one time versus how much was extracted by using 15 mils, but 5 mils, then 5 mils, then 5 mils. And so I can see that by our numbers, it was definitely better to do it 5, 5, and 5. So there would be a lot more extracted with the 5, 4, and 5, 5, and 5 than it was on the 15. All right, that is the end for extractions.